Have you ever just stopped and wondered, how does a bird fly 3,000 miles and somehow find its way back to the exact same nest? Or how did ancient sailors even begin to navigate a totally featureless ocean? These aren't just questions about geography. They're about a kind of secret language, the language of direction. And today, we're going to decode it, from the compass that's built into an animal's brain to the one that completely changed human history. It really does start with this mystery that feels, well, it feels like magic, doesn't it? You've got a bird or a fish or even a butterfly traveling thousands of miles, only to show up right back where it started. I mean, this isn't just about a long trip. It's about some kind of invisible sense that they have, a sense that we, for the most part, seem to have lost. And right there, that's the big difference between us and them. For animals, finding their way is just innate. It's effortless. It's like they have an internal compass hardwired right into their brains. But for humans, for us, it's a learned skill, one that can be incredibly difficult, and for pretty much all of history, we've had to rely completely on tools we invented. So let's start there, with the animal's secret. How in the world do they pull off these incredible feats of navigation? What exactly is this internal compass that's guiding them on these epic journeys?
And look, we're not talking about a quick trip across town here. We are talking about 3,000-mile journeys crossing entire oceans. Can you just imagine the precision it takes to navigate that kind of distance and find your way back to the one specific nest you left months ago? It's just an astounding feat of natural engineering.
So what's the secret sauce? Well, the leading theory is that these animals are tapping into something really fundamental, the Earth's magnetic field. It's thought they have a biological compass, a sense called magnetoreception, that lets them literally read our planet's invisible lines of force, guiding them along these pathways that we can't even see.
Okay, so before we can really get how humans finally figured out how to navigate, we have to go back to basics. I mean, the most basic directional concept of all, something we take for granted every single second of our lives. So let me ask you a really simple question. What is down?
All right, let's do a quick thought experiment. Picture yourself standing at the North Pole. Simple enough, right? Your head is up and your feet are planted firmly down. That feels universal, totally absolute.
But hold on, here's the twist. What about someone standing at the South Pole? From where you're standing, they are completely upside down, and yet they feel perfectly normal. They would also insist that their head is up and their feet are down. So who's right?
Well, the answer, it turns out, isn't about our position at all. It's about a force. Down is simply the direction towards the Earth's center of gravity. That powerful, invisible pull is the true universal anchor, the reference point our bodies instinctively use to orient themselves, no matter where we are on the globe.
And here's the perfect proof of that. Just take that force away and everything changes. When astronauts get into space and escape Earth's gravity, they lose all sense of up and down. They literally can't tell their head from their feet. Without that gravitational anchor, the whole concept of direction just dissolves.
And this idea of a central guiding force, it isn't just for our planet. It scales up to the entire cosmos. It turns out the universe is filled with invisible signposts, and they're all based on this very same principle.
You know, it's amazing how ancient wisdom often captures these huge scientific truths with such beautiful simplicity. This verse from the Quran, it perfectly sums up the two fundamental principles of navigation in just a handful of words.
So let's break that down. We see two different scales of navigation here. Landmarks, that's our local guide here on Earth. A coastline or a mountain range. But the star, that represents something way bigger. Any celestial body with a strong center of gravity. In the vast emptiness of space, it's that gravitational pull that gives you the ultimate direction.
So gravity is literally bending the fabric of space and creating these pathways. These gravitational currents are like invisible cosmic highways. Any object, whether it's a tiny meteor or a man-made satellite, gets pulled onto these paths, following the unseen geometry of the universe.
Which brings us right back to the human problem. So animals have their internal compass. The universe has its laws of gravity. But what about us? For most of our history, we were just profoundly, deeply lost.
Yeah, we don't have that built-in GPS. I mean, think about a little kid in a museum. They get totally absorbed by an exhibit, they turn around, and in a split second, that sinking feeling just hits them. Mom is gone. They are completely disoriented. That vulnerability, that's a fundamental part of being human.
Now just take that feeling and scale it up to the size of an ocean. For centuries, sailors were basically like blind men tapping around in the dark. The sea was literally called the Sea of Darkness because once you lost sight of land, you could just drift for weeks, completely lost with no real hope of ever returning.
Humanity was trapped by its own geography, completely unable to cross the world's great voids. But then came an invention, a simple little needle that changed absolutely everything. It was a tool that finally allowed us to read the planet's secret language. But the journey of this invention was incredibly long. I mean, the magnetic properties of lodestone were known in China way back around 2000 BCE, but it took centuries for that knowledge to travel and get refined, finally leading to a practical seafaring compass that was perfected by the Italians in the 14th century. And that one innovation, it launched the entire age of discovery.
So how does this magic needle actually work? Well, it's beautifully simple. The Earth's spinning iron core acts like a giant dynamo, creating this huge magnetic field all around us. The tiny magnetized needle in a compass is free to move, and it just naturally aligns itself with those invisible lines of force, always pointing towards the magnetic North Pole.
But here's a crucial detail. The needle points to magnetic north, which, believe it or not, isn't the same place as geographic north, the actual point our planet spins on. This little difference is called declination, and expert navigators have to account for it if they want to plot a truly accurate course. And with this simple piece of tech, humanity was finally unlocked. Explorers like Columbus and Magellan could now confidently sail completely out of sight of land. They could cross that sea of darkness. They could connect continents. And in doing so, they completely redrew the map of the world. Forever.
Millions. That's really the legacy of the compass. It went from this revolutionary, world-changing invention to a tool that's just everywhere. It's in our cars, it's in our phones, it's even in our kids' toys. We now completely take for granted this incredible power, the simple ability to always know which way we're facing.
So, in the end, this is really a story about translation. Animals are just born with the ability to read the Earth's magnetic script. We weren't. So we did what humans do. We invented a translator, a tool to make an invisible force visible. And it just makes you wonder, right? What other natural languages are all around us, just waiting for the right invention to help us finally understand and navigate by them?